is I'm going to label them equations A, B, and C so we can refer to them quickly. Now, I prefer to use elimination. Now, this one's not set up to work for substitution well at all, because the only variable you can really solve for easily would be x here in equation C. But elimination works pretty well. I'm going to start out by doing A and B to get rid of x, right? But we notice something funny that happens here. 2x plus negative 2x is 0, cancels out. Negative 3y plus 3y. It also cancels out. So now we have 5z plus negative 2z is 3z, and then 19 plus negative 13 is 6. 3z equals 6. Two variables disappeared on us. That's not necessarily a bad thing. Now all we have to do is divide by 3, z equals 2. That doesn't happen very often, but when it does, it makes life a lot easier on us. Now, the key to the next step, and this is where a lot of people get confused. They get all excited. We found a variable already, but then now what? So the key is, what equation have we not used so far? C. We have not used C at all. So that's what where we're going to go next. We're going to take equation C, and I'm going to replace the z with 2. So this is going to be x minus 2y plus 3 times 2 is 6 equals 11. And now I'm going to subtract that 6. So x minus 2y equals 5. So I'm going to keep that as one of my equations for now. Next, I'm going to pick one of my other two equations. Doesn't matter which one. I had to use C because I hadn't used it at all yet. But A or B, I can use either one. I'm going to choose B. Can anybody tell me why? Because in B, the x is already negative. The y's, I'd have a 2y here, 3y, and 2y, it's not. I don't really want to try to cancel that out. But with the negative 2x here, all I have to do is multiply this one by 2, and I'll be able to cancel out the x. So I'm going to go up to that one. I'm going to replace the z with 2 again. So I got negative 2x plus 3y minus 2 times 2 is 4 equals a negative 13. Now I'm going to add 4 to both sides. I'm going to get a negative 2x plus 3y. Negative 13 plus 4 is a negative 9. So now I have those two equations. And I'm going to proceed to multiply this top one by 2 so that it becomes 2x minus 4y equals 10. And then negative 2x and positive 2x. This is out. 3y, negative 4y. Negative 1y, or just negative y minus y. Negative 9 and 10 is a 1. Divide by the negative 1. Y equals negative 1. So far, I have y is negative 1 and z is 2. I need to find x. I can go back to any of my original equations. I'm going to do this bottom one. So I've got x minus 3 times a negative 1 plus 3 times z, 3 times 2 equals 11. Just making sure that's correct. So negative 3 times negative 1 is a positive 3. 3 times 2 is 6 equals 11. 3 and 6 make 9. We subtract 9 to get x equals 2. So 2, negative 1, 2. What do you think? How'd you do on that quiz that we gave you yesterday? Ready to turn it in? Okay. Which one? The third one? Yeah. All right. What I want to do is I want to go over number 2 a little bit. Just because number 2 is not necessarily like anything we've seen in the past either. I have to go over here. Everybody who's turned it in so far had this one right, so I'm not uncomfortable doing this. I'm not giving anybody an unfair advantage. Where would I start on this? Yeah, the bottom one. 3z equals 12. I can find z really easy from that by dividing by 3. Z equals 4. Well, now what? Well, up here, this equation has only x and z. If I put a 4 in there, the only variable is now x. I can solve for x. 2 times 4 is 8, so this is minus 8. Adding 8. 5x is 10. Dividing by 5. X equals 2. And then, going up here, x is 2, so 3 times 2 plus 2y plus z is 4. So this is a 6 plus 2y plus 4 equals 4. Combine 6 and 4, so this is 2y plus 10 equals 4. Subtracting the 10, 2y equals negative 6, and divide by 2, y equals negative 3. So 2, negative 3, 4. Not so bad, right? A lot of times in the real world, there are missing pieces in these equations that make it easier. Every one of those missing pieces simplifies things. Now, when we left off last week, we had started to touch on matrices. Do you guys remember how to do that? Find that determinant quick in your notes for me then. Let's see how you did. So 4 times 7 is 28. That's my down diagonal. Now 2 times 3 is 6. 28 minus 6 is 22. How many of you had 22? Good. And then we stepped up. To that. Give that one a shot in your notes quick. So the first thing we have to do is rewrite those first two columns. Then we're going to start doing our down diagonals. 4 times negative 1 times 2 is negative 8. 3 times 4 is a positive 36. Negative 2 times 5 times 7 is a negative 70. So that adds up to be what? Negative 52, is that correct? Is that what you got for the downs? 42 is correct, you're right. So now going up. 4 times negative 1 times negative 2 is a positive 8. 7 times 3 times 4 is an 84. 2 times 5 times 3 is 30. Is that 122? So we've got a negative 42 minus 122 equals a negative 164. How many of you got that? No? See where you went wrong? Okay. So I promised you that this week we would tell you why we care. Why do we want to know this? Well, because we can take a system of equations. Like this one. And we could solve it with elimination. This one's set up to solve really easily with elimination. But I'm going to define 3 matrices. I'm going to define number 1, my base matrix. My base matrix is a matrix that contains the coefficients of the variables. So the first column is going to be the coefficients of the x variables. So that's going to be 5 and 2. The second column is going to be the coefficients of the y variables, which would be negative 3 and positive 3. Very good. Notice I put that in the straight lines instead of the square brackets, which means we're going to do what with it? Find its determinant. 5 times 3 is 15. 2 times negative 3 is a negative 6. 15 minus a negative 6 is 21. That's the determinant of my base matrix. Next, I'm going to create an X matrix. Now, the X matrix, kind of counterintuitively, is the matrix without an X. We're going to remove the X variables, the X coefficients, and we're going to replace them with the constants. So this is going to be the constants and the Y's that go in here. So instead of the 5 and 2, we're going to put in 13 and 1. And then we do have negative 3 and positive 3 here. So 13 times 3 is 39. 1 times negative 3, negative 3. 39 minus a negative 3 is 42.
Doesn't matter what column y is.
Yes, it does. It's always x then y, so then the x when it gets replaced, the c has to go first. The next matrix, the y matrix, is the one without the y's. We're going to replace the y values with the constants. So this first column is now 5 and 2 again. It's the x coefficients. This is 13 and 1. So 5 times 1 is 5. 2 times 3 is 26. 5 minus 26 is negative 21. Cramer, important mathematician named Cramer. Nope, it's okay. Oh wait, they do spell with a C in this book. You're right. Sorry. Is it a K in this book? Okay.
We should go ask him.
Dig him up. Ask him what his name is. Hey Kramer, how do you spell your name? I believe it is a K. But you can double check me if you want to.
The C in the index.
Is it?
It's a C.
How dare they? They did put it as a C here. Yep. Well, we were both wrong, so you're in good company. Cramers Rule states that the value of x in this system of equations is equal to the determinant of the base matrix over the determinant of the x matrix. Now the term for base matrix, they just usually use a capital M. For the x matrix, they use an M with a little x by it. Did I do that right? No, that should be the other way around. X matrix over base matrix. It's been a while since I've done this. So the x matrix is the 42. The base matrix was a positive 21. 42 divided by 21 is 2. What do you think the value for y is going to be? Determinant of the y matrix over the determinant of the base matrix. What's the determinant of the y matrix? Negative 21 or 21. Negative 1 is y. So 2 negative 1 is the solution to that system of equations. Not so bad? I'm sensing a sigh of, well, just a sigh. The reason I show it to you is this is the way computers do it. This is the way, the calculator I showed you the other day. Yeah, you're putting in the columns, you're putting in that extra column, which is the constants, and the calculator just automatically uses that column wherever it needs to, and then does the output like that. So what do you think would happen if we had a three-variable system of equations? Well, my guess would be that the value of x would be the x matrix over the base matrix, just like with the others. The value of y is probably going to be the y matrix over the base matrix. What do you think the value of z is going to be? Something called a z matrix. What do you think that is? You're going to replace the z's with the constants over the base matrix. So here's what I want you to do. Partner up if you want to. I want you to use Cramers Rule. Find there's going to be 4 matrices you got to find. The base matrix, which is the x, y's, and z's, and then the x matrix, the y matrix, and z matrix. Find those 4 determinants and see if we can find x, y, and z. And we'll talk about this. Okay, let's take a look at this. First, the base matrix. 3, 2, 5, negative 5, 2, negative 4, 2, 3, 1. Is that what you guys have for the matrix? Okay. 3, 2, 5, negative 5, 2, negative 4. 3, 2, 1 makes 6. Negative 5, 3, 5 makes negative 75. 2, 2, negative 4 makes 16. So this makes negative 85. Going up, 5, 2, 2 is 20. Negative 4, 3, 3 is a negative 36. 1, 2, negative 5 is a negative 10, which is a negative 26. Giving us negative 85 minus a negative 26, which is a negative 49. Those are base. Is that what you got? Negative 59? Yeah, 59. I'm sorry. Helps if I can subtract. Okay, now for the X matrix, put in the 11, the 21, and the 11 here. The X and the Y and the Z stay the same. So 11, 21, 11, negative 5, 2, negative 4. Going down. 11, 2, 1 is 22. Negative 5, 3, 11 is negative 165. 221 negative 4 is negative 168. Is that correct? Equals a negative 311. Going up. 11, 2, 2 is 44. Negative 4, 3, 11 is negative 132, I believe. And 121 negative 5 is a negative 105, which gives us what? What's that? I was going to say something's wrong there. I got a negative 193 here is what I'm getting. So negative 311 minus a negative 193. I'm getting a negative 118. This is the MX. This is the M. So that tells me right away that X has to be what? Negative 118 over negative 59 is 2. That's my X. How many of you got 2 for X? Hadn't got that far yet?
I was going to do all that.
Did you guys get the picture? Okay. Yeah. It does. Works really well. For 120 bucks, you can do that too. I wouldn't recommend it. It's not worth it. We're only going to do this for a couple days.
Only a couple days. After the election started.
Then it might be worth it. What's that? You think it's worth it?
Yeah. We're not going over the.
By the Y?
What?
You want to go over the Y matrix? Because we're running short of time. I wanted to give you a couple minutes of work time here. On page 418, it's exercise 17-6. Solve each of those systems. 1 through 9, the odds. Using determinants and Cramers Rule.